Hello, Algebra 1. We are going to do 9.7 today, solving systems of linear and quadratic equations. We're going to solve them two ways. The first way we will solve by graphing, and the second way we will solve using algebra. So, our vocab is just system of linear and quadratic equations, which means it's a set of two equations. One of them is quadratic and one of them is linear. When you have a system of linear and quadratic equations, you can have two solutions, zero solutions, or one solution. So if the line that you're graphing goes through the quadratic parabola twice, you have two solutions at this point and at this point. If they do not touch and will not ever touch, then there's zero solutions. And if they touch just once right at the vertex, or I guess it doesn't always have to be right at the vertex, but if they touch only once, then there's just one solution. So let's go ahead and graph this to see what kind of solutions we come up with. So let's graph the quadratic first. And if you remember, hopefully, how to graph quadratics, we can start with the y-intercept at 1. Okay. And then I think I will use the negative b over 2a. So I have negative b is a positive 4. And 2 times a is 2 times 1, so 2. So I have 2, and that's my x value of the vertex. And then I need to plug that 2 back in to find the y. So I will go ahead, 2 squared minus 4 times 2 plus 1. So I have 4 minus 8 is negative 4 plus 1 is negative 3. So this is my vertex at 2, negative 3, right here. It opens up. So this is my line of symmetry with the vertex. And I can plot this point right here. And this looks like it's going to kind of, whoops, I totally missed that. Kind of look like that. Okay, let's graph the linear now. Remember y equals mx plus b? I'll just write it. Where that plus b is your y-intercept and your m is your slope. So I have negative 1. And then it looks like I'm going down 1 to the right 1, down 1 to the right 1. And I think I can kind of draw a line here. And if you look closely, I don't imagine because I can't draw very well, but it looks like it's going to hit right here and right here. So those should be my two solutions. So I have 1, negative 2, and I have 2, negative 3. Now, graphing isn't always 100% accurate because you have to be very detailed. So it's a good idea to plug these back in to make sure they work. Okay? So if I plug the 1 in for my x, I would get a negative 2 out in both of these equations. And if I put a 2 in for my x, I would get a negative 3 out for both of these equations. Okay, let's move on to solving by algebraic methods. Using algebra is going to be a more exact answer, and it is preferable. So let's do this. I have two examples here. Our first step is to solve each equation for y. So as long as we get a y equals on both of those, then we're in good shape. Okay. So this one's already done for us like this. And then we're going to put this in for this y right here. So now it looks like 2x equals x squared minus 4x plus 5. And now we just solve it. So let's get 0 on one side. So I'm going to subtract 2x. And I get 0 equals x squared minus 6x plus 5. And then I can solve it however If you want to use a quadratic formula, by all means, go for it. I think this one's easy enough to factor here with a x minus 5 and an x minus 1. And because negative 5 and negative 1 will multiply to a positive 5, and they'll add to a negative 6. And then I'll set each of these equal to 0. So I end up with x equals 5 and x equals 1. Of course, I'm not done. I just have my x's. I need to get my y's too, because these are points. So I'm going to plug in and it doesn't matter which one. I'm going to plug in my 5 for my x. In this case, I get 10 out. So that means one of my answers is 5, 10. And if I plug a 1 in for my x, I get 2 out. So I have 1, 2. And it's a good idea to check it with this one as well, just to make sure that those are the correct answers. We'll go ahead and do this one too. I do have this how to solve a linear and quadratic system algebraically, and those are the steps we went through, but I'm sure this is in your book. Let's do this. These are already set up the way we want them, where they're solved for y. So let's go ahead and just substitute this in for this y right here. So I have 4x plus 3 equals negative x squared plus 3x minus 1. And then I'm going to get 0 on one side. I think I'm going to move these ones over so I don't have a negative leading coefficient. Yeah. And then I will also subtract the 3x, and I will add the 1. Then I get 0 on this side. So that's going to look like x squared plus x plus 4 equals 0. It doesn't look like I can factor this one, so I'll use the quadratic formula. So just in case you forgot, I'm just going to write it down right here. Negative b plus or minus the square root of b squared minus 4 times a times c over 2a. And I'm going to pick out my a and my b and my c so that I can at least do the determinant, and then I'll know how many solutions I'm supposed to have. So my a is 1, my b is 1, and my c is 4. So let's do that b squared minus 4ac. So I'll write that out. Just the stuff under the square root. So I have 1 squared minus 4 times 1 times 4, like that. So I have a 1 minus 16 or negative 15. Oh, remember, if this is negative, that means I have no solutions. So this set of the system of linear and quadratic does not have a solution. What's probably happening is they are graphed so that one is going down like this and one is up here like this, and they will never actually touch. So there's no solution. So just remember that you can have 0, 1, or 2 solutions for these. And I'm going to hop back here because they can look like this. So whether you do it algebraically or graphically, it depends on what they are to know if they have 1, 2, or 0 solutions. So let me know if you have any questions. I think you need about 3 graphs maybe to do on your assignment. So good luck.